box they can plug in, and they can use that. So they don't have to use a web server. It's got a built-in web server they could use, but they could use that. Or we've got some software that goes on a PC that you could also use. The ZTH, what we call it, is a little orange box. That's the quickest way to verify the flow. You plug it in, a couple of clicks, and you've got the flow. So as long as you get
And that one, you're not plugging into the Cat 5. You're plugging into a small port that we have on top of the actuator.
We use flow control valves that are they're not electronic, they're mechanical. I mean, in addition to the valves that we put in and everything, and the flow control valve, they have pressure taps and things like that. And just like you said with the 5 to 50, I think if I'm right, I mean, all we do is tell our balancer, just go to each air handling unit, look at that differential pressure. If it's within that range, it's fine. Just check it. Just check it. Make sure it's in that range. They don't do anything. They just, if it's not within that range, then I'm not sure, what they can do. But we just have them check it. If it's in this range, then it's controlling to the flow that we've specified. Or it's at least, it's controlling to the flow that we've specified. So that's what we tell them. They just check it.
Yeah, right. And you're using basically flow limiting devices.
Yeah, exactly, exactly. It's not a flow control. It is limited.
Yeah, you're guaranteeing a max that you
Exactly.
won't go over, but that range, all under that, you can still be flowing up to that
Exactly,
max.
exactly.
Yeah.
But my point simply was that, as long as the pressure's within that range, then the valve is doing what it was specified to do. It's limiting at least to that flow. It's not unlike what you're doing here in terms of the balancing situation. If I had bought one of these, I'd just go say, check the differential pressure. If it's within 5 to 50, the valve's doing what it's supposed to be doing.
And that's what we do here on our mechanical pressure independent valve, which is, if you guys aren't familiar, this is what our mechanical pressure independent valves. Everybody else will make something similar. A lot of people came out with, or used to make pneumatic valves or pneumatic actuators, so their design looks more like a pneumatic design. But basically what it is, you've got an inlet and an outlet. Water flows from left to right in this case. You got a pressure upstream, pressure downstream. We've got a channel board here for our downstream pressure. Our upstream pressure is sensed here. And then we've just got a spring with a known ability to absorb the pressure differences. And then there's this plunger. So as the pressure increases on the upstream, it pushes down. Less water flow through these channels. So it's pretty simple. Basically, we're guaranteeing we've always got that 5 PSI across our valve, our ball valve. So this is basically like a pressure heater. Any excess pressure, it eats it up, absorbs it, and guarantees 5 across that.
On the flow sensors there, you mentioned they're ultrasonic on the small ones, and what was it on the magnetic on the larger one? Is there straight pipe diameters upstream, downstream?
Yes,
required. If you get a cramped, mechanical room, are these
pipe.
still applicable?
Yep, 5 pipe diameters on the inlet. No requirement on the outlet.
Okay, so you got to have at least 5 straight pipe diameters on the inlet.
The size of the valve pipe diameters. So if you got a 1/2-inch valve.
Yeah, okay, all right, I see what you're
Not your
saying. Yes,
pipe.
right, not the line size, the valve size.
Correct.
That's after they've reduced so if you
Yeah,
put
so
a
if you
1/2-inch
got-
valve on a 1-inch line,
Then 5
you gotta
pipe
have
diameters.
a 1
2.5.
inch, a half
So
inch.
it's 2.5.
Right, 2.5 inches.
Right.
And these can be installed, it's designed really to be put in return to the system, but it can be installed in the supply. It's easy to go into the settings and just basically tell it it's in the supply, or you'll get a negative LT. And we always talk about chill water, but I just want to make you guys aware that hot water is a good application too, especially condensing boilers. You're trying to maintain a certain return temperature to stay in that condensing range, 130 degrees or whatever it is. You want to stay in that or below that, temperature to really get your efficiency. Otherwise, just leave your 80% boiler in and let it run.
You were talking in the presentation about the 500 GPM delta, which is for water. If you have a glycol system, can these be, set up for
You actually go
glycol
with
as
the
well?
valve and you tell it how much glycol is in the system. And then the smaller ones, the ultrasonic, can actually determine how much glycol is in the system. It won't tell you, but it will know based on the viscosity of the fluid. All fluid it's at a specific gravity, a certain viscosity water, once we introduce, you know, propylene or ethylene glycol or whatever, it's gonna change that. And you know, the way these things work basically is, you know, in this case, there's a signal that goes this way. There's basically, if you look inside this thing, there's two posts in there. They're chamfered off, so this is chamfered off this way and this one's this way. They act as mirrors, so it's sending a signal this way, and then this transmitter is sending a signal this way. The time it takes from it to get here, over to here, tells us how much flow. So different viscosity. Imagine putting oil in here to make it, you know, understandable. It would take a lot longer to get through that thick fluid than it would be to get through just water. So same way with the magnetic flow meter. You've got a magnet on the bottom, magnet on the top. As you introduce more resistance, it takes longer for that signal to travel.
But if you're doing, you know, the energy control, it'll take the glycol into account. It's
It
not.
always takes the glycol.
Okay, I mean, if you tell it there's glycol, it'll take that into account. It's not.
We have to
gonna
do it
use
just for
that.
flow, regardless of energy. We need it for flow.
Right.
Because we need to, so it's always there, and then, you know, whichever features we turn on. So Don kind of talked about it, but, so you can set this up as a pressure dependent valve, but then you can also turn on delta T manager or power control as a pressure dependent valve. Same way with pressure independent, you can turn on delta T manager or power control. So,
And the other thing I didn't mention, all the data collection can be done in any of those modes as well.
yeah, as soon as you plug the valve in and put power on it, you're getting data, you can't stop it. It's gonna collect data for the life of
Yeah.
the valve, you cannot stop it.
Can you adjust settings in the field? Like, you know, you said it's set up at the factory for the flow you specify. If that changes, can that be field changed?
Up to the maximum, yes. Yeah.
Right. So that's a physical limitation, that maximum, right?
Right.
Right, yeah.
Correct. Yeah, and then we talked about 5 to 50 PSI. If you get below that 5 PSI, you basically derate the top end of the valve. So if you have a 500 GPM valve at 5 PSI, at 4, it might be a 480 GPM max valve. Down to 1, you've got significant derating, but hopefully you're not doing that. Just FYI.
And then one other thing I was gonna mention, back to the pipe diameters ahead of the valve. You know, the valve is still gonna work if you have less than the 5 pipe
Yeah, it's just an
diameter.
accuracy degradation,
Exactly.
right?
The accuracy of the flow sensors.
And these are
How about
2%.
longevity of that calibration and recalibrating it, ultrasound, water treatment, all
No,
affecting it?
no recalibrations required. Anything else to say about that?
I'd say,
No, it's a sticking point. No recalibration is required at this point. I've looked at a lot of other manufacturers of flow meters, and you know, for the most part, they're not really recommending calibration either. Recalibration. So it's 2% accurate. It's not. You know, we've had some pushback from I don't know, a handful of people when they're doing metering or something and trying to bill somebody with 2% accuracy. I'm thinking, oh, okay, 2% accuracy is still pretty good. I mean,
right.
you know, you're not talking a lot of difference in, you know, 1,000 GPM, 2% accuracy was at 20 GPM or so.
How are the performance contractors estimating, because they're having to swag payback and things of that nature when they're doing the building?
We actually have some estimators. On the back of that brochure that was in the front, it looks like this one, but you guys can write it down. Just real quick. Back in this, energyvalve.com, down here on the bottom. Highlight that or write it down somewhere else. But energyvalve.com has everything that you ever wanted to know, and then some about the energy valve. So the case studies, presentations on the case studies, all the tools we talk about. But there are also savings estimators on there, and they get pretty involved. Okay? It's really about 10 pieces of information you've got to have, and it'll come out and give you net present value, future present value, you know, all those things that when you're talking to a CFO or somebody that you want to bring forth. It may not be, you know, as important to the guy that's actually working on the system, but the guy that's, you know, writing the checks, he's going to want to see some of that stuff. But it gives you simple payback, ROI, you know, some of the things that you hear more, but then there's those, I guess, higher level financial metrics like net present value and things that some people really look at. And when you get into your bigger companies, your bigger campuses, your corporates, that's something they're gonna wanna see, so.
And that's something if you want myself and or Brian to come in with you to talk to these people, we'd be happy to bring that information with us and all three of us sit down and talk about it.
I mean, a way to help calibrate it. I mean, I'm thinking of a building right now, that bigger facility, there'd be a couple dozen valves, but I gotta figure out a way to prove out the savings.
Sure.
Yeah, and it's, we get that spreadsheet, basically it's a spreadsheet. It's got about 5 tabs. We look at the weather data, all those factors. And then we look at cost, obviously. We determine what the cost is, and then we work backwards from that. So we need things like numbers of chillers, tons, energy costs, the standard stuff.
Okay.
These can all be hardwired back into the EMS system.
Yeah, you can do BACnet MSTP or BACnet IP, but really all it needs is a signal, a 2 to 10 volt signal. You don't have to hook it up to anything special. The Delta T manager will work with just a 2 to 10 volt signal.
But you can monitor it, you hook it back up.
If you hook it up to BACnet, you get all those points. You can change whatever is capable of being changed. You could plug an Ethernet cable in, put it on your LAN, and then you could go to that web address, or that IP address, and you would see the horseshoe-looking pipe that we showed you in the valve in it and all that information. And then you could go in, you get some trending data, there's quite a bit of information, but you can also hook it straight up to BACnet, trend that stuff yourself, do your own graphs, reports. I've recommended to people lately that
What's your baud rate on those?
it's, figure.
What's the max?
I usually don't get into
I
that.
haven't even asked you about unit load on it yet,
Yeah,
so.
don't ask me that. We can talk later.
If you can hook it up to BACnet IP, you can also still hit the web server.
No.
No, so you have to choose.
Yep.
Oh,
Yeah, one or the other. Or one would communicate, one or the other, just leave that, one or the other. Or you can do BACnet MSTP and the web server at the same time. But we've only got one Ethernet port, so you can only do one protocol, either our web queue we call it, or BACnet IP. Sorry. But the graphic that Don pulled up, I see no reason why anybody couldn't just take a picture of that, a screenshot, or build it yourself. With the exact same data we've got on our graphic, and make it look basically the same. So, and you can trend faster or slower or whatever you want with your own system. We're limited to 30 seconds, and then when we take so basically we take 30-second samples for 31 days, and then we take an average of those for the 2-hour samples, and we save that for a 1-month sample.
So how many points are coming into BACnet? I mean, if it's BACnet, you're seeing it live, I assume. What's the trend?
How many points do we have in the valve?
Yeah, I mean,
I
is it
think there's about
both per-
25 or 30. About 25 or 30 valve.
if you have it set up for BACnet IP, how do you get in to change settings on it? Like a switch where it goes back to the
But
bus
you
and
could,
change stuff?
you could write to any one of those points once you have it over BACnet.
Okay, so the same configuration you can hit from the web, you can also see it via the points.
Yeah, you can turn Delta T on and off, you
Yeah.
can tell the power control on and off, or, you can change it. Or you can go out and unplug it, or you could plug the ZTH into it, which is a different port.
Yeah.
Not ideal if it's a 20-foot ladder that you gotta climb up between two
The
ducts.
ZTH is
and
kind of
provide.
default if for some reason things go haywire, you lose your IP address.
It's a
whatever, your
handheld,
CCD,
easy to
you
use.
just
Yeah.
be your default.
Yeah.
I see the ZTH as something that a lot of the techs would have on them, if they need to change something quick, they've got this little handheld ZTH, they could go in, for example, if you ordered the valve program for 60 GPM, but you needed 75 GPM, easiest way to do it probably be to just go into the ZTH up into the 75 GPM.
How much more expensive is this, and what's,
Let's
you
talk
know,
about
a standard, I mean, you say typically we'd save this much for that much extra money.
As
I
far,
mean, in general, I know, you know, there's a lot of
yeah.
factors.
As far as this versus just a pressure independent valve,
A mechanical pressure.
a mechanical pressure independent valve, this is 20 to 25% more than just a mechanical pressure independent valve. And that
Just a pressure dependent valve, you're about 15 to 20% for mechanical from pressure dependent to pressure independent. But once you get, the thing is about, once you get to about a 1 inch, this makes as much sense as a mechanical pressure independent, because you start getting close to that same cost.
1 inch going up.
1 inch and going up.
Yes.
Instead of using a Griswold DC.
Yeah.
And because you also gotta think, you know, you're eliminating hopefully some of your, you know, balancing cost, but you're also eliminating circuit centers, right? Flow control, flow limiting devices, whatever you wanna call it, and the installation of those. So, you know, we talked about this, and a plan and spec job, I mean, I did it for a long time, guys, I did a lot of, you know, estimates and all that, and I would count VAV boxes, whatever, I knew what it cost per VAV box was. That's how I estimated the job, didn't really always look at the specs, right? And I kinda knew what I was gonna put in. Same way with the mechanical guy. He's gonna look at it, he's gonna say, I got, you know, 82 VAV boxes. I'm gonna say, you know, I know a triple duty valve costs X for this, so it's $400 a box, boom, I'm done. Well, now we didn't get that savings because, you know, he's still working off of pressure dependent. You know, the guy's been in the business 30 years.
He's gonna save the money if he gets the job, but he didn't factor it in.
But the guy that looks at the plans and specs and does it right up front might get the job. So, you know, it's a shift, and, you know, pressure dependent and has been out like 50, 60 years since valves were made, right? Pressure independent, the last 15 years, something like
15
that.
to 20, yeah.
And, you know, I call on the engineers in the Midwest, so basically 7 states, and I go into any city, and I can find 5 people that love pressure independent, and that's all they wanna put in. And they talk about their customers and first costs, and, you know, and how they sell them, or they, you know, they talk to them and show them the benefits. And then I got 5 guys that will tell me, I don't wanna hear anything about it, I don't believe it, it's smoke and mirrors, and it's not smoke and mirrors, but those guys, you know, they're set in their ways, they do these cookie cutter type things, right? This is what we do. We've got the design already done, 90%. We're just gonna push it over here and stamp it and be done.
Be
So
more
the guys that
likely
don't
to
like
change.
it, though, are not because it doesn't work, but because they don't
It's-
believe that there's benefit.
It's perceived cost for one. I mean, there's all kinds of different, you know, engineers, right? Some of them are really afraid to go to their customers and, I guess, kind of step out of their comfort zone and then show them the cost. But when you start looking at I mean, you look how many valves we've got on a project, and what's the total cost of those valves for the total project. So we talk about 20% more for a valve, but that may only be $3,000 on the whole project for 15, 20 valves. So people hear these numbers, oh, 20, 25%, that's a lot of money, but you're gonna spend $100 million, and I'm talking about $5,000 or something like that. And you're gonna save all this energy, and you can't control how much energy costs. You control how much this valve costs because you're gonna buy it today.
So what would a typical payback be on going with
I
this?
do a lot of them, and I see anywhere from about 2 to 5 years. But I see some that are half a year. I mean, it really depends on the building and the system.
Right, sure.
But
But in general,
roughly about 2 to 3 years would be
Okay.
the average on when I do my
Okay.
estimates.
Well, the other thing is, in looking at some of the smaller valves, we've seen where, in looking at 1/2 and 3/4 inch valves, if you just take the total installed cost into consideration, rather than just the unit price of the valve,
right,
the fact that you're gonna eliminate the need for a circuit setter or some type of balancing valve, you may not need to have the balancer go to each coil, but balance the system as a whole. Some of the savings that you can achieve, on the 1/2 and 3/4 inch size, you end up seeing that the pressure independent ends up costing less total installed than pressure dependent. But because, you know, the guys that are bidding it, they're so used to bidding pressure dependent. Even if it says pressure independent, they still throw in a balancing valve. Even if the spec, like Ryan was saying, he didn't always look at the specs. Well, if there's a pressure independent valve in there, if the engineer is doing it right, they should have eliminated the need for a balancing valve where they have that pressure independent valve. Now, whoever places the bid may not do that.
Yeah, I've told a lot of engineers to put a breakout on your bid form for pressure independent. You know, start changing the mindset that way, making somebody break it out and show it. That way you got, 5 contractors on a job, and they've all got, $5,000, $5,000, $5,000. This one guy's got $10,000. He must have done it right. Everybody else just kind of threw something on paper and shut it off, right? But
I've seen other companies that, offer the pressure independent and everything. Is there anybody else offering, the energy part of it, the DT management, and the energy control? I mean, I don't know of anybody else.
there's nobody that offers.
I mean, in the US.
No.
Not that I'm
Not
aware
the
of.
world. On the
Oh, really?
electronic side, nobody else has a flow meter with a valve, basically, built
Right.
in to make a pressure independent electronic flow meter. Electronic pressure independent. But just real quick, before I forget this, we talk about this energy valve and all this, but this is pressure dependent to pressure independent, okay? So that's the savings between the two technologies. And this is nice, this is, Delta T Manager, but if you would just go in, and we've got another product called the EPIV, which basically is the same thing,
This product without these sensors.
and it doesn't have backnet, doesn't have a web server, but it has a flow meter. We'll give you the feedback, so you can hook that feedback right up to your control system. So a 2 to 10 out and a 2 to 10 back. That 2 to 10 is scaled up to flow range. So with that product, or with our mechanical pressure independent product, this is the savings they would have got. This is just, icing on the cake.
But the EPIV doesn't have the temperature sensor? Is
It
that
doesn't,
correct?
it doesn't have a BTU meter, so it's a
Right.
flow meter and a valve.
It's just flow.
Just a flow
Right,
valve.
okay.
But, it's, so you've got pressure dependent, say 15%, you've got EPIV, 15% more cost, you've got energy valve. So, I'll tell a lot of people to put the energy valve on all your big air handlers. I've got one job where they're putting them on every VAV box. It's a new school going up, they're gonna put these on every coil. But if the cost is an issue, put these on your big coils. Maybe put the EPIV on some of your medium-sized coils or smaller coils. And then put mechanical pressure independent on everything else. Just make it all pressure independent, so you get that savings, but you don't have to have a BTU meter for every VAV box. You add all those VAV boxes up, and they're bigger than probably any area in the building, right? So it's still a considerable amount of energy, but space becomes an issue, cost might become an issue.